I'm very sorry. I cannot actually upload the homework. It was supposed to upload previous Monday, but well, I cannot have a chance to upload it. Well, anyway, I will put it Thursday, and well, it also, you know, you need to solve it by the end of the homework. Actually, I think that is the end of the homework set of this class. Actually, maybe is that? Do you want more? If so, well, I think if we really have time, I really want you to have a chance to build, design the wastewater treatment, plant actually, not plant, just unit process, aerobic reaction tank, so that you can use learn how to use all of the kinetic and equilibrium concepts and rate constants. Then how they can be applied for the design of the reactor. Well, anyway, I think you guys don't want that. You really want that. If you really want that, I can put it as a final exam. You want that, right? So. You guys will have one homework set. So the total homework set will be 6 or 7. Well, anyway, you guys all know. And one more thing that I want to talk to you about the class next week. I will be out of town. I will be headed to the Denmark. I will visit Denmark Technical University next Monday, so to Friday. So I really cannot have lecture for you. So there is 2 options. First one is having makeup class before, after visiting, or if you are okay with the my PhD students lecturing to you, well, one of them can give you lecture. So which one do you want to have? Students. So you don't write my lecture?
Because the exams are soon and we don't have time for makeup classes.
Yeah. Okay. Well, so you give me very reasonable. You hurt me actually. All right. Well, anyway, I think I teach not because environmental engineering part is really taught introducing a bunch of environmental technology. Well, that would be good as an introductory, but I think you can learn the wastewater treatment technology from Professor Shin. It is kind of junior, class. Environmental engineering courses for juniors. So you can have some wastewater treatment technology from Professor Shin, and also you can have some water treatment technology from Professor Park. And also, you can have some biotechnology from Professor Han, I think. couple of hours introducing bunch of environmental technology, I don't think they are good enough for you to fully understand. So so here I just introduce you how to design the reactors, batch reactors, from batch reactors to continuous reactors. And then now I am teaching you how to obtain the rates, rate constant. As we already have talked, you guys can take it from experience. And also some statistics to get those experimental values. Well, think about that. Is that a real, solution? I mean, as I already told, 1 plus 1 equals 0, right? In the mathematics. But sometimes, one cell, one female cell plus one male cell, cannot create, 2 cells actually. If a reaction, biochemical or chemical biological reaction occur, 1 plus 1 cannot be, 2, right? So this is very, very important thing. Knowing the reaction things. So people at first time, I mean, maybe 14th centuries or 16th, 17th centuries, the life of the the daily life of people is very simple. There is just one big question. You believe in God? Yes. Okay. You can live. Not. If not, well, go to hell. That's it. Very simple, right? And then some kind of Renaissance, era just put out some creative, some rebellions. I cannot say rebellion, but rebellion started to think about, is God everything for their lives? Then they think about what is proper thing and what is good thing and what is good for the human life. And some rebellions start to think God is created by human being, Then something complex, something not complex, something very simple story. It is based on the ancient mathematics and ancient physics. So the physics running from this department, civil and environmental engineering, well, actually started from Egypt and the very ancient Greek and Rome. It was started from there, and it was actually developed by the 14th, 16th, 17th centuries European physicists actually. Newton and those guys actually put some concepts. So you are running the statics and the dynamics of the power to build bridges actually, right? But the important thing is 1 plus 1 equals 2. Very, very, good thing. You don't have to worry about the. Is there any other things which needs to be considered by God's will, or by some black witches curse or something like that? Very simple word. But here, environmental engineering, biology, and physics, chemistry, you really need to think about many things. So, the statistics actually started from the kind of rebellions against the simple, physics and mathematics. Actually, those concepts, those lessons cannot give them any exactness and any properness. So they think about why this reaction, why these experimental results, why this kind of cases happen. So think about that. And then they want to know, or they want to pick the results. Well, you guys can think about the start of the statistics. Well, the initiation of statistics actually from the gambling places actually. Everybody want to know. Everybody actually win the game and take the money. That is the starting of the statistics. So, what is best? What is most important thing in statistics? Tom, what do you think about that? What is it?
The most important thing is to find the laws of appearance of event.
To find appearance of what?
To find the law of the appearance of a particular event.
Particular event. Yeah, right. So that means events. I mean sample and the experimental results are very, very important. Well, sometimes if you enter the graduate school, Professor Huang from Seoul National University, well, he was very close to the Nobel Prize winning, to self-copying, animal. He was very famous at that time. So old Korean actually, talk to him, talk to the government, will give him money so he can win the prize, right? There are many, good professors actually in KAIST, and at that time it was 5 or 6 years ago actually. He also had 20 or 30 graduate students in his research lab actually. There is one master student whose name is Person Ah. He was graduated from Korea University, and then he applied 4 times to enter Professor Huang's laboratory because she wanted to be a scientist and she wanted to publish her experimental results as Science and Nature. Think about that. Her, undergraduate was not that good, but she started to know she has kind of talent in research field. Study brain and research brain is a little bit different. As I already talked to you, some of you, study is kind of a sprint game, running. It is just like Usain Bolt actually run the 100-meter, but research is kind of marathon work. So sometimes it needs creativity, but sometimes it needs more, patience and such kind of sweats and tears and even blood, sometimes. So Person Park, actually entered the Professor Huang's laboratory after 3 years. She applied 6 times, and the Professor Huang started to know, wow, this girl is very, very, Well, think about that. Somebody is just, looking for you, wanted to be with you. I think that is very, very, big thing anyway. Even men and women relationship that works actually. So never ever go anywhere. Just stay there, but don't this is important anyway. Well, she entered and she did some biomolecular analysis work actually. Well, most of you think biomolecular analysis is kind of very high-tech gizmos, right? So it needs very high, tech technology and needs, difficult, knowledge. Yeah, right. It is. But the important thing is, in Korean proverb, you can do one work. Just eat and do the work. Repeat it 100 times. Repeat it, before you die. You can do it. 밥만 먹고 그것만 하냐고 하는데 밥만 먹고 그것만 하면 여러분 분명히 일은 이루어져요. So she did it actually. So well, she actually entered her laboratory, Professor Han's laboratory, before the sun, shining. She never ever went to the toilet and just doing the molecular analysis, sitting on the chair, 6 hours and 7 hours, 10 hours. Then she ate her lunch lately and did the same work, 6 hours more. And she left for sleep around the 10 o'clock. So she never ever, seen the sun shining actually during her graduate, days actually. She found very important, concept for copying, well, there are many, copying things, Professor Han's achievements actually at the time. One of the important concept was proved by her experimental work actually. But important thing is, she really wanted to be a very good student to Professor Han. So there are many cases, let's say 10 cases, but couple of cases cannot. If those 2 cases are used with 10 cases, the probability, the credibility of the experiment can be falling down. So what she did is just take out 2 cases. Well, you can say, you can actually, in your case, you enter the graduate school and you have 30 cases. 28 cases show O and 2 cases show X. If you really want to, very good student, and if you want to see your professor smile, you may think about just remove 2 and show 28, experimental cases as a whole, right? So Ursun actually wanted to, do that. So she just removed a couple of experimental, cases. Professor Huang was very, surprised and very, happy because she thought that cannot be, verified actually by that, he just do some, some evaluation test if that can, verify. But also just gave him kind of, possibility. Her designing, experimental designing actually can verify some very important experimental hypothesis for publication as Science and Nature. Wow. So Ursu is kind of very core member of Professor Huang's, group actually. Although she is master's student, not the PhD student. Most of the students there actually graduated from Seoul National University, and a couple of students actually graduated from outside. Think about that. the environment is not that easy. So what she did is she just running her version of the statistic program in her head, and which can make his advisor happy. But it is not related to scientific things. That is the problem. She actually continuously working and do a wonderful job. It was kind of very time-consuming, experimental work. But she actually did it around the 1.5 years, actually. And then Professor Huang decided to publish his experimental work publish at the Science. They prepared and put it Science. And then the newspaper actually, introduced Professor Huang publishing that experimental work as Science. Ursula was very happy. But she was very surprised and very disappointed when she looked at the paper as Science, because she cannot find her name on the list. Wow, it is kind of, I did my best for my boss, and my boss just betrayed me. Wow. What can you be thinking in that cases? Is she, continuing her research work for his advisor? Well, what she did was she just write an email to the Science and to the other, government, and then she just report what she actually did. And then, interesting thing is, Science and Nature level, Angewandte Chemie is very good chemistry journal. Those kind of journal is kind of a good, advisory board. If some scientist actually raise some kind of question, he just read or she just read the paper, and he or she find some different or some not bad results in the paper. He or she can ask Science or Nature just to verify the experiment, so that the Science actually organized verification team from Germany, from United States, from Russia. So 16 actually organized to verify the experiment. But unfortunately, no group actually verify. Show the experimental results again by following Professor Huang's protocol, actually. So the Science Committee actually announced Professor Huang's experimental work is scam. Wow. And he was falling down so far. I think he is very wonderful scientist, Well, he did some kind of polyprofessor work too, but although he did it, there are other many important achievements. But that one, that work done by his graduate student actually take him from the sky, to the bottom actually. So, from this case, what do you want to be? Well, important thing is, when I, be a professor, I really, do the nice to the all students. Well, you should do that. That is very, very important. If you are boss, you should be very nice to your students. But always, very be proper and very reasonable. That is also important thing. And then, as a student, what you should do is never ever cook data. Think about that, Delphine. You are making one very nice novel carbon nanotube, diamond nanotube, and then if it is, synthesized and proved, you can win the Nobel Prize. But you have 30 cases. Just one case shows wrong results. If I just talk to the people, I never ever did the one case. I just have 29 cases and I have 29 okay. In that case, well, there is two Delphine appeared. One said with the horns said, well, Delphine, you just remove that one, you can win the Nobel Prize. And the other white one with wings say, never ever do that. So what you should follow? What do you want to do? Well, at the there is another interesting, cases for Cavendish Research Institute. Well, it is kind of Millikan's, particle theory. So Millikan actually did the 16 cases, and then he just say, I have 9 cases is okay and the remaining is wrong. He reported and he just published in Science, and then he won the Nobel Prize. But interesting thing is his experimental report notes. In that case, after he died, the researchers actually checked the cases in his notebook, and he cannot find the same number. So Nobel Prize committee actually did the same thing, but it actually turned out Millikan's work is right actually. So anyway, important thing is if you want to be a very big star, never ever lie to others. Well, actually, you don't have to lie because statistics can actually support you. Statistics never ever say to you, you are wrong. Well, you may heard about the Richter scale, right? This is, let's say, this is experimental results. And this is kind of, predicted. And this is experimental result. We are talking, this is real one. So experimental results means kind of, the Bible, God's word. So never ever touching that. Never ever cooking that. So in this case, using the sum of Richter scale, let's say this is y and this is x minus ax squared. So y minus x minus ax squared, which makes smaller is the Richter scale. Well, anyway, as I already talked, if this one is R scale is 1, this means all the experimental results is on the line. The experimental results and the predicted line are the same, right? But sometimes you can have R scale is 0.5 and R scale could be 0.9, right? So this one and this one, you cannot say you're wrong. You're right, but you have R scale level 0.5. This is okay. Yeah. So statistics actually support you and estimate you the properness and exactness of the estimated data. This is very, very important. Well, right here, we are talking about the rate, right? Rate is sometimes delta C over delta T, and sometimes it could be minus K0 or KCA and KCA scalar, right? So how can you get the K value? These K values can be obtained from this kind of statistics, right? So, well, I think I am giving you a little bit, not related actually, story from the Professor Pons, But important thing is, well, this is very, very important. Never ever touch the data. This is kind of, Bible, God's word. If you touch this, well, the tragedy actually starts. And the statistics actually support you, Actually, in this case, well, Tom has R-squared. Tom's experimental result is R-squared equals 0.5. And he has 0.9. Well, I can say he is excellent. And I can talk to Tom, you suck. But you are right under the R-squared equals 0.5. Yeah. This is the power of the statistics. All right? Okay, so, well, talk about the statistics part. Think about the, let's say, and think about the batch reactor. So from here, how can you get the K1 value here? Well, simply, you can measure the concentration A, and then with respect to time T. And here, you can have many different time concentration. And one thing, let's say CT T1 minus Ti minus 1, and you can measure it using some kind of analytical probe. And then you can also check the time. And then you can measure CT also. And you can measure CTi plus 1 also here. Right? And then delta C over delta T equals, well, as you guys know, CTi plus 1 minus CTi minus 1 over Ti plus 1 minus T, like this. And also, you can have plus 1 minus T I plus CT I plus 1 minus CTi, like this. Okay, this is just for the batch reactor case. And what about the proper vector? Well, that case, you can use only one vector here, because important thing is time t and the concentration of A. These are what you that you needed to obtain this one. But proper vector, important thing is you're dealing with the theta, right? So as I already talked, to obtain the theta under the same flow rate, you really need to have different volume. So here you can have vector 1 and you can have vector 2 and different type of vector n. You can have different theta 1, 2, theta n like this, right? So here also you can check the concentration of A. So CA here. So also you can get the RA and C theta. Using the same probe, you can check the all values here. What about the completely mixed CFSTR? In this case, RA, CA, theta, you can also check all of these values. Here, RA equals just like the delta CA over delta theta. And the RA here is theta CA0 C like this. So you can just plot the concentration with respect to RA. Well, sometimes you can see the zero order. And you can see first order. And you can see the second order. And sometimes, actually I'm teaching environmental chemistry, advanced environmental chemistry in graduate school. I really have very strong interest in the microbial and abiotic. Biotic means, microorganism related. Abio means A means not. So it is not just a no microorganism direction. So sometimes we really, if you want to deal with those two biotic and abiotic cases, you also need to run microbiology. That is very important. You may have heard about the Monod equation. Anybody from microbiology? Nope. Monod equation is kind of microorganisms growth. So the concentration of microorganisms put, and this is microorganism, growth rate, and microorganism actually, think about this. In this beaker, you just have microorganisms. We call it Pac-Man microorganism. And then add the concentration of microorganisms to here. And the growth of microorganisms, the first time it increases very fast. And if although the concentration actually increased, the growth rate of microorganism actually saturated. Right. This is the same thing, you know. What do you think about the? Well, microorganism is kind of representative of animal, which can represent of humankind. So the same thing. Just to put you limited, a space, and then start with 1 cup of soup, and then give plenty of time, and we can see the growth actually. The growth means your growth and the regeneration of the cells, and then increase the number of cup of soup actually. Well, what about the what kind of trend can you find? Can you find the same trend as microorganism show? Any idea for this? Take it. What's the difference between microorganism and humankind?
The growth dynamics.
Yeah. So my first question was, let's do the same experiment, as we do here. Let's start with, let's say this is 1 milliliter cell, and put 3 microorganisms. And then let's start with 0.5 amount of food at this time, and then increase. Maybe 3 could be good for these 3 microorganisms, and increase to 10 or increase 100. Mono, I really don't know his nationality. I think he is Italian or French, or I don't think this guy is British. So he just showed the if you increase the concentration, the growth rate, as he said, growth dynamic actually follow this saturated curve. This is what mono equation tells. So my question was, if you are doing the same thing here for humankind, well, somebody can say, why do you want to do that? We are humankind. So we have, we believe in God, and why do we want to do that? I just want to know, anyway. So my first question was, what kind of trend can you guys find? Do you believe we humankind show the same trend as the Pac-Man microorganism showed, proved by Mama? Misa, what do you think about this?
I don't think so, because human can 한국말로 그냥 할게요. 그러니까 사람은 자기가 생각을 해서 그러니까 개체수를 조절할 수 있고, 그리고 아까처럼 스프 하나로는 사람 한 명도 살아나기 힘들기 때문에 마이크로오르가니즘과 같은 패턴이 나타나게 될 것 같습니다.
Misa's answer was humankind have intelligence, so they manage something. They did not follow. They don't follow microorganisms protocol because they can think. So what about what kind of trend line can you expect? Is this just like this, or because they started to know we cannot have enough food, so we will die pretty soon, and they commit suicide altogether because they have intelligence. I want to die, in peace. So, like this. Or if there's zombie around here, Mike.
Well, as far as I know, according to demographic statistics, the trend is completely opposite.
Yeah.
And that is because humankind can actually expand the resource base based on industrial innovations. So when we have not enough food, we think about something new, and then we go to new. We expand our spaces.
But let's say we have limited space.
But we have not reached the limit of the Earth, but we might be reaching it in the nearest future.
The basic assumption was we are doing the same, experimental. We have the same experimental condition here. I can allow you. We can actually. We can increase the amount of food actually. It could be by the development of industry, or it can be the production of farmers products. Well, anyway. So if so, what's your trend line? What could it be? Exponentially, like this. Is it okay? Take it over there.
마이크를 나오겠는지 모르겠습니다.
Okay, Michael's answer was because humankind's increasing the number of the humankind on the earth is kind of totally. I cannot say totally, but it is quite a contradict to the trend line of this microorganism actually, because we actually develop the industry and we can produce more. So under this experimental condition, the growth actually, exponentially actually increase. That is what he said. Do you want to add more? Right. So, understand? 진짜요? Any further question? Actually, this is one good experimental reports done by U.S. Scientists. They actually did the similar experimental work at the middle of the desert in Arizona. They have very limited space because NASA want to send people to the moon someday, and they just assume everything perfectly achieved. Well, we can go to Mars, and we can go to the moon, and we can set up the cosmic construction at the surface of the Mars and at the surface of the moon, and then just send some troops or send some scientist group, and then what happened there? Everything was provided by science. They can raise rice and vegetables, but limited space and limited sources actually. They did 30 years experiment. Wow, 30 years. But important thing is nobody can go out from the start. Well, actually, there is kind of very thick reports. You can find it actually at the bookstore or even library. Some female scientists actually commit suicide actually. Yeah, because she has intelligence. Well, anyway, this is very, very important thing. Well, I'm not gonna, talk anymore. If you have further interest in this one, just check. I really cannot remember the book's name. It is kind of Arizona cosmic something that actually entitled from the building name. So Well, anyway, but I think although this is my version of the hypothesis. Although people with intelligence, under the very limited environment, we just do the same thing as the microorganisms do. Or maybe like this, because we believe in something, right? So if I live in this state, I'd literally die in pits like this. Well, I believe in it. Please check. Well, first is I really did many not interesting things. All right. Okay, I think I will finish the statistic regression part for obtaining the rate constant for the environmental candidates next time Friday, and I will finish it. Maybe you guys can have one more week, right, before the final. So I think as you guys say, maybe PhD student will give you kind of example how this kinetic plate can be used for the designing of wastewater treatment. Okay, any question?
We also determine when you obtain the final
Unfortunately, student representative is always busy. I think your question was, do you guys need to make some consensus for, having final exam time and venue, right? Well, I think that is what the student representative need to do actually. But the important thing is, 기철아, 그게 좀 이런 말이 좀 and also, you really need to inform the international students too.
네.
Actually, she or he actually asked me several times. So that is very, very important. All right. Well, for the final exam, I talked to you. It is kind of it'll be cumulative, right? So, but the important thing is mostly 70% will be in the later part. So the reason why I make this exam cumulative, because I want you to have good grade. Because 30% it is kind of bonus points for you. Don't you want that? Please let me know if you don't want that. I will put all the exam on the later part. Nope. Tapping. Nope. Nope.
Secondary is quite difficult compared to the first part. So.
Yeah. It is just kind of, I just want to build the wastewater treatment plant with plug flow record, and the flow rate is like this and like this, design it. Yeah, and 80% per 100%. Just kidding. Well, the important thing is homework is important. And one more thing, presences, I really don't care about the presence, but you guys really, so presence is one good, point. So do it with me by the end. All right?
Professor,
헤이, 잠깐만. 그리고 프레젠스라고 이야기를 했는데
예.
물어봐야 됐다.
지금 해야 돼요.
Sit up, guys. 수영이 안 왔지? 기용이, 오케이. 희건이 왔고, 준태, 효빈이 안 왔지? 대현이 왔고, 그지? 대현이 왔니? 마이클. 예빈이, 아디카 왔고, 세윤이, 재환이, 맞네. 우기, 미소 왔고, 건이, 혜림이 안 왔나? 혜림이 안 왔지? 태규 왔고, 희철이 왔고, 선정이 왔고, 그 다음에 승주 왔지?
네.
그래. 가려고 그래. 경연 왔고, 탕 왔고, 쌤 왔고, 델핀 왔고. Important. One more thing is you really need to think about the scholastic honesty and scholastic dishonesty. That is very, very important. Well, you really need to take, the honor and the money and the power. Well, some people, very talented people, can take all together power, money. What is one more thing? Honor. Yeah. So that is very, very important, but difficult thing. But as a scientist, you really need to, take the honor. So never ever commit a stupid thing. Don't lie. And one more thing. This is kind of warning. Again, don't copy your friend's homework. Man, shame on you. I just checked, 5 cases actually. Those could be actually 0. I really want you. Alright?